Good morning. Good morning, everyone. Myself, Mounika. I'm working as assistant professor from the Department of CSC at Marri Laxman Institute of Technology and Management. So today, I'm gonna discuss about the fundamentals of machine learning. So these many topics will be covered in this session. Let's see the first one. What is machine learning? What is the need of machine learning? And what is a well-posed problem? And let's see there some examples of well-posed learning problem. So first one, what is machine learning? So machine learning is defined as a field of study that gives the computers the ability to learn without being explicitly programmed. So previously we will do the traditional programming to achieve any task, but with the help of machine learning we will expect the results, or we will predict the decisions without giving any explicit programming. Okay, so this is how a ML works. So it involves the feeding data into the algorithm to identify the patterns and make predictions on new data. So here we will feed some data, like we will feed some previous data to the system so that the system will generate the so here we will give some old data or any previous information to the system that will be feed to the system. Then the system will converted that particular data into algorithms. That algorithms will predict some new results. Okay, so let's see this diagram. So we have a deep learning, machine learning and artificial intelligence. So deep learning is a subset of machine learning. So when we are learning machine learning, we need to know what is deep learning first, and then machine learning. Machine learning is a subset of artificial intelligence. When we are learning artificial intelligence, we need to know what is deep learning and what is machine learning first. So let's see the need of machine learning. So nowadays everywhere we are using the machine learning techniques. Let's see. So machine learning is a core form of artificial intelligence that enables machine to learn from the past data and make predictions. So as we have discussed earlier, we will feed some information to the system so that will predict the outputs. Okay, so here some specific examples that will correctly define the machine learning. Let's see, the first one is NLP, that is natural language processing. Okay, so here the NLP stands for natural language processing. So this is a language which will predict the human language so that we can so that the system can easily understand the human words. And next, image recognition. So nowadays we are using so many photographs in any media, like say in social media we will upload so many photos, and in Instagram we will tag so many photos. So the capturing any image from any social media, that can be easily possible with the help of machine learning. And next, speak recognition. So this is the ultimate option that was given by the machine learning. That is like example, let's say we are using smart TV in our home. So with the without typing any word, we have an option called voice. So in like we will speak something, and that will be displayed on the system, right? So this is how. So here we are missing, so there is no need to type anything on the screen. So with the help of voice, so the system can understand what we are speaking, so that it will display the related content to us. So this is how a speech recognition is possible with the help of machine learning. Next, self-driving cars. Self-driving cars, as you know, like nowadays we are using self-driving cars. The cars are already designed with some set of instructions, like, so whenever a red signal is there, then the car will definitely stop. Then otherwise any human is passing through the in front of the car, then the car will stop. So we will give some steering instruction like go to left, right, so that we will reach our source to destination, so that the car will be designed in that way. So we will give some information prior to the car, so that the car will move according to our instructions. So this can be also possible with the help of machine learning. And next, product recommendation. So nowadays when we are doing shopping online, right? So let's say we are searching for any item, let's say watch. So I have opened one application like Amazon. I have searched for one product. So that product will get displayed on. So whenever I'm searching any Titan watch, so the related watches will get displayed on the screen. Okay. So once I close the application, whenever I'm opening an Amazon application, that will definitely display the different kinds of watches in the home page itself. So every time whenever we are getting or connecting to the any application, that will save our information, our likes or dislikes, so that the system will show the related content to us. So these are the examples where the machine learning is used. So let's see what is well-posed learning algorithm. So a computer program is said to learn from the experience E in context to some task T and some performance measure P. If its performance on T, it was measured by T, updates with the experience E. So this means any problem when we are taking, that should be divided in three ways. Okay, let's say we are doing some task, that will be called as action, or any event will be considered as a task T. Okay, so the performance of the task can be measured with the help of P. So whatever the experience we are gaining with the help of that particular task will be measured by E. So these are the three important traits for this well-posed learning algorithm. So any problem can be segregated as well-posed learning problem if it has three traits. Okay, the first one is task, then the performance measure, and then experience. So let's see some examples of well-posed learning problem. So here I have taken three examples which will definitely efficiently define the machine learning, well-posed learning problem. Let's say first one, handwriting recognition learning problem, a robot driving learning problem, and the third one, chess learning problem. So these are the three examples which will define the well-posed learning problem. So let's see the first one, handwriting recognition learning problem. So here the task will be recognizing and classifying the handwritten words within the image. So we will write anything, like that system will not understand, right? So here we will give some instruction, like we will give system with some predefined images so that it can capture the image and it will define the content. So what we have written in that particular image. Okay, and then the performance can be measured, like, so whatever the words we are writing on the particular image of anything, so that can be classified in a proper way. Okay, so let's say we are using some English, Telugu or Hindi. So here the words can be classified into each and every part, so that the performance the percentage of words can be classified. So this is the language, so here these are the words can belong to this language, so that we can categorize the particular words. And next, training experience E. So here a data set of handwritten words with given classification. So here we will give some input information, like we will give some data sets. In that we will give some classification. So this is this language and this is that, and like we will give some different kinds of information, so that the system will get some experience. Okay, so this is how handwritten recognition learning problem can be possible. And next, a robot driving learning problem. So as we have discussed earlier, task. So here the task is to driving the car on a road. Okay, so driving on highways using vision sensor. So here we have some sensor so that it can identify what is in front of the car. Okay, so let's see the performance measure P. So average distance traveled before an error. So here we will give the instructions to the car, like we have to travel from A source to some B destination. So this is how the performance can be calculated, like is it going in a good way or it is like we have any error. So this can be calculated with the help of performance measure. Okay, Then the training experience, a sequence of images and steering commands recorded while observing a human driver. So we will give some input information like how a human is driving the car, so how he using the steering, how he using brakes and all. Okay, so this is how we'll give the training session to the particular uh, particular data set to the system, so that the system will understand, then the system will run as per our instructions. So this is the robot driving learning problem. And the last one, HS learning problem. So as we know, in like we used to play, like we will be playing chess in now, like every day. So here the task is, first the task is to play the chess. Okay, so this is our task. Next, performance. So the performance, like when we are playing chess, we will usually have two players. So the percentage of games won against the opponent. So here our performance can be measured with the winning, right? So here once we win, we will get one credit. So same like the performance measure can be calculated with the opponent's loss. Okay, so this is the performance measure. And next, training experience. So training experience can be possible. So we will give the system that how chess can be played, like how a camel will move, how a horse will move. So we will give some data set, so that the system will play the chess. Okay, so by playing the chess, the system will understand this is how the instructions were given to that particular system. Okay, so this is the chess learning algorithm. And coming to these references, so these are the different kinds of websites that I have taken the information. Thank you.